Hi, I'm Kevin Hauser. This is the 10th and final video in a video series that I've done in support of my new book, the Ubiquiti Radio and Access Point Handbook. It's available on Amazon. One of the big things that I wanted to talk about, and I saved this one till the end, is the need for more throughput. We're talking about Unify now. So in the indoor access point world, one of the big concerns these days has been I need more throughput, I need more speed. I have 46 devices in my home that I need to support, including a car in my garage that needs massive updates, probably an electric car. This becomes more and more problematic because of the technology we have today, where we have just bandwidth-hungry devices and lots of them. When I started teaching probably 7-8 years ago doing wireless, the number of devices in somebody's home was somewhat limited. It might have been a Nest thermostat, a few other things. Now it's multiple users with multiple devices, with watches and laptops and tablets and iPhones and television sets and you name it. There's so many things out there. So it has become well understood in the wireless world that we need to provide support for those devices. So what are some of the best ways to do that? And I want to kind of outline that here. What are some of the best ways to do that? So we're going to go through a quick presentation on the need for this speed and the need for this throughput, and hopefully we can intersperse some good ideas along the way. So we're going to have some good ideas, and stay tuned, and we'll also even talk about some new standards. So hold on. Okay, so as I mentioned before, home use of wireless is constantly evolving. It's driven by more devices, more connections, and bandwidth-hungry applications. We are going to need to future-proof some of our Wi-Fi. If you think about what's going on in the homes now with 4K video, high-density wireless office, and it's amazing how much stuff that we're going to have to support. So one of the biggest questions I get is, how do I get that done? What are some of the best ways to do that? So let's talk about some of the best ways to do that. How can I do that with my existing equipment? Okay. I need more speed. So that seems to be the biggest complaint. That seems to be the biggest comment. I need more and more and more throughput. I need more speed, more throughput. I have a gig fiber to my house, but internally I need more throughput. I need more speed. How can I accomplish that? Well, you could go to your APs in your home, and you could use much larger channels. Larger channels will allow for more throughput. Here's the drawback to that. Larger channel will end up using more spectrum, and because it's using more spectrum or more space, there'll be more noise that's associated with that particular connection. So if you have lots and lots of wireless devices, you may have problems using larger channels. Also, the PSD are also what is known as power spectral density. The density level of the signal that you're getting, or the signal quality, will actually be diminished on larger channels. Smaller channels have a better PSD rating. You get a much cleaner signal with smaller channels. So again, somebody might say, hey, well, just, crank your access point up to larger channels. And that sounds like a good idea, but depending on how many devices you have, you may need to reconsider. Now, again, I hate to harp on this, but my book goes into graphic and detailed explanation on these relationships. Okay, what else could we do? We could use high-performance access points. Ubiquiti sells a line of HD and XG access points that are super high performance, right? They're designed for large number of connections, large number of users. They deploy beamforming technology. They have multiple radios embedded into these radios. Now, there isn't a huge drawback to this, except cost. Cost is higher. Also, I put a comment in here that I oftentimes tell my students, buying better golf clubs doesn't make you a better golfer. What I mean by that is some people will just try to plug in a high-performance access point thinking that will solve all of their problems. You still have to design your wireless LAN, and you still have to allocate channel assignments, and you still have to do your due diligence when it comes to coverage and capacity. So just plugging in a high-performance AP isn't the end of the story, not for everybody. It certainly isn't, right? Another recommendation that we talk about in class, use smaller cells, deploy more access points. This is probably one of the better ideas that you could do in your home. Instead of one giant HD or XG covering your 10,000 square foot McMansion, you might want to have, multiple smaller APs that are less expensive covering areas that are specific, bedrooms and living rooms and basements and that sort of thing. However, the drawback to this is redesigning your wireless network can be kind of time consuming, can be costly, having to run more cable, and it can get rather complicated. But this is probably the best idea of these ones that I have here. So let's look at an overview here. What things will improve your speed? Larger channels. That would definitely improve your speed. Buying an access point that has support for multiple spatial streams. Multiple in, multiple out when you see a 2x2 or a 3x3 comment on the radio. Higher levels of MIMO will increase your speed. Radios that have better modulation rates. Radios that have higher capacities. These are definitely things that will improve your speed. Better signal to noise ratio. This is why I recommend smaller cells, because we are going to get a better ratio of signal to noise. If that AC light in the bedroom provides better coverage than the HD in the living room 300 feet away, then we will get a better SNR and the client will have a better wireless experience. All right, hold on. We're going to come back for something else. Okay, what do I mean by something else? Recently, Ubiquiti has brought out a line of access points that are running Wi-Fi 6 or the AX standard, 802.11ax. The reason I mention this, there's currently only two on the market. There's an AC Lite version and there's a long-range version. The long-range version of this Wi-Fi 6 unit is a 4x4. It has 4 separate antennas for sending and 4 for receiving. I would highly encourage people to go to the UI.com website and under products and under Unify, look at the specifications for this particular new access point. This is completely different than other access points that previously that Unify has created or has marketed. This standard was built from the ground up. This was not an improvement of standards that we've previously seen. In previously lifetime versions of 802.11, we saw working groups, that's the letter designation behind the 11, A and B and G and N. These were all basically working groups that were tasked with, hey, improve this older standard and make it better. All right, and so currently many of our access points are running in the AC standard. Well, AX is not built from an improvement level. It's not designed to be built on top of AC. This is not what it is. This is a completely new standard written from the ground up. Now, it does support AC devices or AC backwards compatibility, but it is not the same. It is completely different standard. I highly encourage people to look at this new standard and go read up on what it does. And I'm going to give you a quick overview on what it does. So hold on. Okay, well, let's talk about Wi-Fi 6. This is the 6th generation of Wi-Fi. And as I mentioned before, this is backwards compatible to the AC standard, but this was built entirely from the ground up. The entire standard was built from the ground up. Now, what are some of the features of AX? AX allows for up to 8 spatial streams. So in the newer AX standard, rather than allow for 4 spatial streams, this device, I should say that this standard will allow devices to have multiple MIMO streams. Again, every time you see a radio that graduates, or you see a standard that graduates from, say, 2x2 to 3x3 to 4x4, you're not just adding one more antenna for sending and receiving, you're exponentially increasing the throughput capability of that radio. Also, I mentioned that the new standard will allow for higher modulation rates. So you'll see something that says 1024 QAM, where a standard AC radio is 256 QAM. This QAM stands for quadrature amplitude modulation. We're converting waves into actual binary data. The higher level of modulation will convert more data. So a 1024 radio is considerably quicker at doing this than a 256 QAM. There's also a new standard. So the new standard uses what's called OFDMA, which will be backwards compatible to OFDM that we use now, but it's a little bit different. So OFDM was used in a radio. This stands for orthogonal frequency division multiplexing. This allows a radio to orthogonally place transmission channels to one another, giving you a cleaner view of that channel and better signal-to-noise ratio. But this was really a one-to-one relationship, where the new standard, OFDMA, can actually talk to multiple clients literally at the same time. This will support more devices. This will allow for much more device support and many more users. You know, those users at home that have tablets and watches and laptops and iPads and Teslas in the garage. Let's look at some of the clever stuff how it does this, okay? So OFDM takes a standard Wi-Fi channel and divides it up into what are known as resource units, or RUs. So now you can assign a client, or the radio can assign a client to a specific resource unit. This allows you to subdivide this channel up. So this is what the radio is doing internally. And it can do it intelligently. So you can see here it says, by subdividing the channel, applications that use small frames, such as video or audio, can be transmitted to multiple endpoints literally at the same time, cutting down on overhead and congestion. What is overhead and congestion? Go to the airport, sit at a gate. There's 10 people waiting for a flight. You go online, you send a few tweets, you check your email, you stream part of a Netflix show, and then when there's 150 people that show up waiting for the flight, there's so much congestion that you can no longer do those things. That's the difference. Okay? That's kind of the difference. So let's stop there. Okay, so as I mentioned, UniFi has two new access points. A UniFi 6 Lite AP. It retails for $100. It is you can only run it or can adopt it if you have a controller version of 5.14.3 or newer. It's extremely fast. It's extremely robust. It has much higher throughput than your standard AC Lite would, with the same form factor, actually, too. And they have an LR version, the UniFi 6 LR. This is retails for $179. You need a controller version of 6.0.34, I believe, to run this and adopt it. This particular radio has 4x4 antennas in both the 2.4 and the 5 gigahertz spectrum. So this is an extraordinarily fast device. This device uses OFDMA technology, so it can indeed use multi-user MIMO. It can talk to multiple users literally at the same time. And that's what it's designed for. Now, I'm sure that Chris will do an extensive review at some point in the future, but for 179 dead presidents, I would run out and buy one as fast as possible. The LR designation means that this particular radio will perform beamforming and probably has considerably more gain. And we talked about the difference between gain and power before. It probably has significantly higher gain levels. And I think that is tremendously important when you have the need for speed. All right, so we're going to talk about one more standard, and then I promise I'll stop talking. Okay, well, 60 gigahertz has arrived. You may see more devices in the future going to 60 gigahertz. You can see that UniFi has a bridge point-to-point 60 gigahertz radio with a 5 gigahertz backup radio in it. So we already do have some new devices, but what is unique about the 60 gigahertz standard? So this is a standard known as 802.11ad. This is a little bit different standard. This standard allows for a very small radiation pattern. So if you think about the output of some of these devices, and now these are outdoor devices, the radiation pattern is super, super tiny, kind of like a laser. So this would allow for lots of devices to be located in the same area. This 60 gigahertz radio lineup that you're going to see as we move ahead, and they do have some, these are extremely fast devices. I have a friend in Canada that runs a WISP, and they have one set at about 1.4 kilometers in distance, and this is just their standard 60 gigahertz Ubiquiti radio, and it's running about 900 megabits per second. The reason it can do that is because there's literally no other interference from any other devices, because nobody uses that particular frequency, that high level frequency. So Ubiquiti and other companies have begun to leverage this open, unlicensed frequency that's very, very high. One of the drawbacks to high frequency is attenuation, or loss of signal, due to both oxygen and water vapor in the air. But they have plans for overcoming that. So the FCC has allowed for companies to crank the power up on these devices. So the power levels will be actually raised considerably. For the techies, it's going to go up to 81 dB of EIRP, which is some ridiculous amount of wattage, about 150,000 watts, eventually. The 802.11ad low power short-range devices operating in this range will potentially offer throughputs of up to 10 gigabits per second. So the future is bright for outdoor radios. Now they're going to create longer distance radios of this frequency, of this type, and the benefit is dual-fold: more throughput, but again, we have a huge amount of spectrum to play in. So in the 5 gigahertz spectrum, we have about 500 megahertz. There's 7 gigahertz of spectrum in the 60 gigahertz range. There's a huge amount of room for channels. So there will be plenty of available channels, which means less interference, which means less noise. And again, because the beams are so small, you're probably not likely to interfere with anybody else or anything else. So the future for outdoor radio is also bright, as well as indoor radio. And the future is here. It's already here. Okay, well, that kind of wraps this video up. I really want to thank everybody for watching and putting up with this for me. I appreciate it very much. I hope everybody rushes out and buys my book. I hope people sign up to take classes. That's also a wonderful thing. As you can see from my shirt, I work for wifi-U, I work for Microcom. These two vendors offer tremendously good Ubiquiti training and very thorough training. Shameless plug on my part. Thank you very much. Again, so thanks for watching. I really appreciate the opportunity to bring this material to you, and hopefully we can do some more of this. Thanks.